Okay, in the world of spaceflight, you kind of expect things to go wrong in a million different spectacular ways. But I can pretty much guarantee you have never, ever heard a story quite like this one. We're not talking about a simple engine malfunction or a guidance error. No, this is the bizarre story of how Japan's flagship rocket just lost its cargo.
I mean, just let that sink in for a second. We're talking about a multi-million-dollar satellite the size of a small truck that's supposed to be bolted down tight to the top of a rocket, and somewhere on the way up, it just vanished. How does that even happen?
You know, the analogy that's been used for this is just perfect because it makes this ridiculously complex aerospace failure something we can all kind of get our heads around. Imagine you're driving down the freeway. Music's on, everything feels fine, but the entire rack on top of your car has just been ripped off, and you have no idea. That's basically what happened here, just on a cosmic scale.
So let's meet the main characters in this whole drama. First, you've got Japan's H-3 rocket, right? This is their new, shiny flagship launcher. And then you have its very expensive passenger, the Michibiki 5 satellite, a 5-ton beast of a machine that's a key part of Japan's own version of GPS. So yeah, the stakes were pretty high on this one. The scene is set. It's December 22nd, and this is the 8th time the H-3 is flown. The rocket lifts off the pad, roars into the sky, and everything looks totally perfect. I mean, textbook. Telemetry is green across the board, the engines are firing just right. For the first few minutes, it was a flawless launch.
But then, things started to go catastrophically wrong. And what's amazing is that the rocket itself was the main witness to the crime, so to speak. We can basically piece together what happened by looking at the data and the video the H-3 sent back in those last few moments.
The whole mission completely unraveled in just a little over a minute. At 3 minutes and 55 seconds into the flight, the payload fairing, that big clamshell nose cone, it splits and falls away. Totally normal. But just 1 second later, the first sign of big trouble. Let's break down the clues. So the very first piece of evidence came from the rocket's own onboard cameras. As soon as that fairing came off, the video feed just lit up with a shower of debris all around the satellite. And then Michibiki 5 started to wobble, kind of leaning to one side. It was a huge red flag that something was structurally very, very wrong. And it wasn't just what the camera saw. The rocket felt it too. At that exact same moment, sensors right where the satellite was mounted started screaming. They were picking up these violent, totally abnormal jolts. This wasn't the smooth push of the engines. This was something breaking apart.
Now here's where it gets even more serious. The damage wasn't just at the satellite's mount. The telemetry also showed a sudden pressure drop in the second stage's liquid hydrogen tank. That suggests that whatever violent event happened, it was bad enough to also damage vital plumbing on the rocket itself. The problem was getting worse by the second.
For about a minute, if you can believe it, the damaged satellite was just hanging on. But then came the knockout punch. The first stage engine cuts off, and the rocket separates from the second stage. That staging event creates a big jolt, and for the weakened connection, it was just too much. The Michibiki 5 was thrown clean off, tumbling away to fall back into the Pacific Ocean.
Well, a failure this big and this weird obviously kicks off a massive investigation. With the main piece of evidence at the bottom of the ocean, the detectives at JAXA, Japan Space Agency, had to work with only the data they had. And their main tool is a classic detective method.
It's something called fault tree analysis. Basically, you start at the end, the satellite fell off, and you work your way backward. You map out every single possible thing that could have possibly led to that failure. Then you use your clues to cross things off the list, until, hopefully, you're left with the real root cause.
So after going through all that data, JAXA's fault tree has given them a short list of prime suspects. These are the top theories for what could have actually caused that first catastrophic blow to the satellite and its mount.
All right, suspect number 1, a collision. Maybe a piece of that payload fairing didn't separate cleanly and just smacked right into the satellite. Suspect number 2 is a little more abstract. A sudden, super violent release of stored energy, like built-up strain, in the actual connection hardware. And suspect 3 is a leak. High-pressure gas or propellant spraying out and acting like a little rogue thruster, pushing the whole thing apart. Now, as part of this whole process, JAXA has already been able to rule a few things out. They're pretty sure it wasn't a problem with the fairing's air vents, and they don't see any evidence that the satellite itself was the source of the problem. The focus is still laser-sharp on that critical connection point between the rocket and its payload.
Look, this investigation is about way more than just one lost satellite.
The pressure to figure this out is massive, because this H3 failure puts Japan's entire space program in a really tough spot. They are absolutely in a race against the clock.
This number really says it all. 2 failures in just 8 flights. That is a really challenging track record for a rocket that's supposed to become a reliable workhorse. I mean, for a little perspective, SpaceX's Falcon 9 has flown successfully over 300 times in a row. Reliability is everything in this business, and right now, the H3 has a big question mark over its head.
And that question mark is hanging over one of the coolest science missions Japan has ever planned. The H3 is booked to launch the Martian Moon's Exploration Probe, or MMX. And this isn't just another satellite, we're talking a flagship, deep space explorer.
And what a mission it is. MMX is designed to fly all the way to Mars, actually land on its tiny moon Phobos, scoop up a sample of the surface, and then fly all the way back to Earth to deliver it. It's an absolutely incredible and complex mission that is totally dependent on the H3 rocket working perfectly.
And that brings us to the final, nail-biting question. See, missions to other planets have these really tight launch windows based on where the planets are. The window to launch MMX opens this October. So, can JAXA's investigators solve this bizarre mystery, find a fix, and get the H3 cleared to fly in time? An entire historic mission to Mars is literally hanging in the balance.